Hello again, algebra students. One more day of radicals. We're just going to put everything back together. Next week, we'll have a test coming up on all of the radical work. So today, just to really feel confident about being able to divide radicals like we started in our last lesson, but also all the multiplying and all the regular simplifying that we've been doing, just kind of throwing everything together. So you can see these first two problems are just multiplying problems. There's no numbers out in front in this first problem. And I personally would not take the time to multiply 15 times 25 and get 375. Because if I did that multiplying, I would probably say, okay, how am I going to split that up? Well, 25 times 15, which is what I have right now. So instead, I would do 3 times 5 and 5 times 5. Everything's in square roots. And here's my pair. That breaks out. The 5 and the 3 that were left over go back together. Now, in fact, I wouldn't even really have needed to make these trees, right? Because we know that this right here is a perfect square. The square root of 25 is just 5. 15 didn't have anything that broke out, so it's just 5 rad 15. In the second problem, that -2 that's in the front, or that's in kind of the middle, actually, it's in front of the second radical, that is going to go out in front of the whole thing. Again, 15 times 20, you could certainly multiply that and get 300. Wouldn't be horrible to do, but I don't take the time to do that most of the time. So I would take my 15 and make a 3 and a 5. And I take my 20 and make a 5 and 4. And then the 4 I can split up a little bit more. So I have this pair of 5s. Remember, they're both in radicals. I know they're in separate radicals, but they're both under a radical. And there's another pair. So I had the -2 that was out in front of that radical. The 5 is going to break out, and the 2 is going to break out. The leftover stuff that didn't get circled is just this 3, not the 4. Notice that the 4 branched out, and we circled stuff up from that. So just the 3 is left. So when I multiply all this back together, I'm going to get -20 rad 3. On this one, again, the 3 is going to come out in front. You could certainly make the 10 times 5 into a 50. Split that up however you would like. I personally would just do this. Say this 5 can work together with that 5, both underneath radicals, so they're good. The 3 can come out in front. The 5 that paired up breaks out. This 2 got stuck, left behind. 15, rad 2 for my answer. In the second problem here, you know the -5 and the +3, both going to pull out all the way to the front, but I'm not going to rewrite it just for that right now. I'm going to split up my 6, which is going to be a 2 and a 3. Split up my 15, which is going to be a 3 and a 5. Again, I purposely wrote it that way so that my 3's were right next to each other. So I had my -5 that was out in front. I also have a 3 that was out in front of a radical. And then I have this 3 that's going to break out. These didn't have partners. They go back together into a 10. So this would be -45 rad 10. So that's just our regular multiplication. We also do distribution when we're looking at multiplication kind of problems. So when we distribute this, the square root of 6 times 4. Now remember that 4 is a regular 4. It's not the square root of 4. So the 4 stays on the outside. The 6 is under the radical. Minus. Now keep in mind, this is all one thing. Don't try to do 2 rad 6 and then also a rad 18. 2 rad 3 is one term. It's getting multiplied by that rad 6. So I'm going to put the 2 radicals together into one thing. So the 2 stays on the outside. Rad 6 times rad 3 is rad 18. And some people stop right here and they say, oh, well, we're done. Nothing matches. But this 18, I can do better than that. Right, the 6, that's a 2 and a 3. There's no pairs there. But the 18, I could do 9 times 2. Break out that pair of 3s. So that 4 rad 6 stays. I'll have a 2. I broke out a 3, and I still have this rad 2 right there that was left over. So this is going to turn out to be 4 rad 6 minus 6 rad 2. And again, just because they both have 6s, that doesn't mean that they match. They do not match. The first 6 is in a radical, the second one is not. Here, again, this 2 rad 10, this is one thing, one term that's going to get multiplied when I distribute. So the 2 is on the outside, but then I have a rad 10 and a rad 2, which becomes a rad 20. Plus, when I multiply this, now I had a 2 on the outside from the first part, and a 2 on the out, just a regular 2 actually in the parentheses. So it's going to be a 4 rad 10. Rad 10 doesn't simplify. That's a 2 and a 5. There's no pairs there, right? You can certainly try it, but you get to here and nothing works. So that didn't help us at all. 20 though, I can go 4 times 5. By the way, I'm sure by now some of you are certainly capable of just saying, well, the 2 times that 2 that broke out, that's just going to be a 4 rad 5. Great. I'm still going to write it down as, here's my 2 on the outside, here's my 2 that broke out, and then I also have a rad 5 that got left behind, plus 4 rad 10. So this is going to be 4 rad 5 plus 4 rad 10. And again, just because they both have 4s doesn't mean they match. The rad 5 and the rad 10, those are different. Our last lesson was about division. So let's take a look at these. Let's use all of the stuff that we know about simplifying. So in the first problem, the 20 and the 9, that doesn't simplify, even if I put it into just one fraction with just that part. However, the square root of 9 is just 3. I don't even have a radical left in the denominator. The rad 20, I'm going to do this down here. It's going to give me a 2 rad 5. Trick question. Can 5s cancel? Answer is no, they can't, because one's in a radical, the other one's not. So in the numerator, I have 2 rad 5. In the denominator, I have a 15, and that doesn't simplify anymore. That just stays exactly like it is. Here, the radical parts can simplify. In the last one, the 20 and the 9, there's nothing that I could divide them both by that would help. Divide them both by 1, but that doesn't do anything. However, in this case, I could simplify just in the radical parts, divide by 3. That'll be a 1. That'll be a 25. So on the top, I'll have a 3 rad 1. Well, rad 1 is just 1, so that's just going to be a 3. And I've got a rad 25 on the bottom. Square root of 25? That's nice. That's just a 5. And again, the top part is just 3. This is just 3/5. Okay. In the first problem, I would start by just saying, well, why do we even have those 2's there, right? We can just divide both by 2. That simplifies somewhat already. 15 and 80, neither one of them is a perfect square. However, I could divide them both by something. I could divide them both by 5. So if I would divide by 5, and I haven't been showing this, I've just been canceling, but if you need to do this, you can certainly do that. Instead of that numerator, then it would just be a 3. And 80 divided by 5 is 16. Notice they're still both in square roots. Gotta have that. If you don't tend to show your division like this to simplify, if you just can say, oh, I'm going to divide them both by 5, here's my 3, here's my 16, it's the same thing. And the square root of 16, that's nice. Square root of 16 is just 4. But square root of 3 doesn't change. Done. And this last problem, again, 12 is not a perfect square. However, I could just look at the radical parts, the 3 and the 12. Let's divide them both by 3. This will be a 1. This will be a 4. So on the top, I'm going to have the square root of 1. Well, we know that's just going to be 1. On the bottom, I had a regular 4 on the outside. And now I have the square root of 4. That means I've got a 1 on the top. 4 times the square root of 4 is just 2. 1/8. And done. So today, the worksheet that you have is simplifying, multiplying, and dividing. All of our radical stuff that we've been doing. The answer key is in Schoology, so feel free to check that. Be careful and use that the way that it's meant to be used. But remember that you might show your work a little differently and still get the same answer. When you're all done, take the formative in Schoology and let me know if you need any help.